Hi, everyone. Happy Friday evening. It's the first chance I've gotten to get back into chapter 4 and the rest of the material associated with it about correlation. I hope your week went okay and you're looking forward to a reasonable weekend. We have to follow up on our extra and bonus material. Another note is that there is an assignment coming up that is not yet published. I don't want to push that out too soon because I don't want to. I don't like to have an assignment assigned before I've finished giving feedback on the last one. I'm still not quite done grading your assignment too. So that's coming. That's in the works. I'm just working away at it. So we did the Whelan Chapter 4 presentation. We haven't talked about the Huff presentation yet. I will take a few minutes just to go through that with y'all. And I'm not going to spend too much time on it, but I want to just highlight a few additional points that Huff makes. I found the Huff reading to be really interesting. It's from an old book called How to Lie with Statistics. And what I found was that I was a little bit ambivalent about my feelings about Huff. I was like, yeah, it's okay. He's kind of an old crank, and I don't know if I like him. And then when I talked to students about it, they said, no, he's great. We really liked it. And so you all can weigh in about that too. If you decide you want to have more or less Huff, you can let me know. Anyway, let's talk about just the high points of Huff. To review the major theme here of Huff, and like the best readings that we had earlier in the quarter, Huff is pretty oriented toward the idea of how to use statistics incorrectly as a cautionary tale. To try not to reinforce that idea too much, I want to make sure to remind us all that my own view is we should learn the value of statistics and also the caution of using them incorrectly. So Huff is a little bit of a series of negative examples that might just leave you thinking there's no good statistics or no good use of statistics. So treat that with a bit of caution or a grain of salt, if you will. Anyway, to review, this is stuff we've already talked about, which is that if we have A correlating with B, it could mean that A causes B, it could mean B causes A, it could mean A causes B causes A, it could mean some third factor causes both A and B independently. We looked at examples of these in the last lecture. I won't review them too much. Or there could be some mediating variable that is unobserved, but that is really important to understand before we can say that A leads to B, because A doesn't lead to B unless X. And so the most important point about all of these possibilities is it's not just that, it also could be a spurious correlation. So we could have a correlation that doesn't have a causal relationship at all. It's an accidental correlation. The really good example of that we have is from our course modules. We go down here to Tyler Vegan's spurious correlations, and there's example after example after example of very strong correlations that are complete nonsense, complete accident. Well, they're not nonsense, they're correlations, but there's no causal linkage. There's no A causing B or B causing A or anything else in there. So could be any one of those, could be none of those. Huff then takes us through a bunch of different scenarios in which we end up with meaningless correlations, or the problem of reverse causation, where we think A is causing B, but really it's B causing A. One of the things that Huff points up is that if we want to cook the books, if we want to find a spurious correlation, it's easier to find that if we have a small sample. In other words, think about those Tyler Vegan examples, which is he looked at a series of years, and he looked at something like statistics like strangulation in bed sheets and number of films Nick Cage has started. I don't remember if that was the correlation exactly, but it was something like that, right? Or per capita margarine consumption by year. And he looked at the per year statistic, and then if you look at the series, it's like 10 or 11 years is all he's looking at. It's a very short time frame. Because all he needs to find then is two things that are going up over 10 years or two things that are trending down over 10 years. He doesn't need to worry about anything more than that. He doesn't need to worry about a long time series where In fact, there might be discontinuities. In other words, I could find something that's gone up over the last 10 years, like the stock market until a couple months ago, and find something else that has increased over the last 10 years, and they would be correlated. But I don't think the stock market causes all the things that have increased in the world, and I don't think that all the things that have increased in the world have caused the stock market. So if we have a very short sample size, a very short time frame, very small sample size or a very short time frame, it's easier to find an accidental correlation. That's an important thing to consider. Sometimes we can have it really hard to find cause and effect because we have a chicken and an egg phenomenon. The example that Huff gives that I already gave you in our previous lecture was the example of wealthy people almost universally own stocks, and people who own stocks are almost universally wealthy. Yes, there are some people who only have a few stocks and are just starting out or relatively poor, but it's pretty rare for poor people to own stocks because they're poor, and it's pretty common for wealthy people to have spare money to invest, and when they invest it, they tend to invest in the stock market. So, is it owning stocks that makes you wealthy, or is it being wealthy that makes you own stocks? This is really impossible to untangle cause and effect, and we actually can say it's bidirectional. I think it's pretty safe to say that people who have money tend to invest it because they have excess funds to invest, and people who invest money tend to make returns on that investment and everything but a bear market. And so that's pretty much bidirectional causation, if you will. And then he brings up this idea, Huff brings this up idea of just straight up spurious correlations. Now, I'm a little skeptical of Huff's skepticism. So this book is now many decades old. I think it was written in the 1950s or 60s, even when there was still a lot of debate about whether cigarette use was bad for you. And so his example was the relationship between using cigarettes and smoking and your grades, and he argued that it was just a coincidence or a spurious correlation, and I'm okay with his general idea, which is that you can make an argument that there's a common cause maybe for both people more likely to smoke and more likely to get poorer grades, but I would also I would listen to people who argue that just using too much of anything is probably not the best thing for your grades in a lot of respects, right? So caffeine, maybe? Don't want to weigh in too heavily on that. I'm a caffeine user myself. So I put the question mark on here because of that. But then he gives some other examples that are like the Tyler Vegan kind of correlations, which are the example he gave was the ministers' salaries in Massachusetts are strongly correlated with the price of rum in Havana. Both have gone up over time. And yet we don't have any reason to believe that the price of rum in Havana affects the salaries of ministers in Massachusetts or vice versa. And he points out that they are both the product of trends over time, which is two things that have been increasing over time. As a matter of fact, it's very easy to find things that are strongly correlated just because things tend to increase over time with inflation, no matter what we're talking about. So you have to be careful about claiming there's a causal relationship when two things are correlated along that way. Another issue that Huff brings up, and he brings it up in a slightly different language than does Whelan, so it's worth revisiting, is the idea of projections. And Whelan brings it up as terms of like projecting into the future, but Huff brings up this idea in terms as extrapolating beyond the range of data. And the example he gives is of rain and corn, but another example is of education and income. And let me grab the tablet here and see if I can illustrate this. And what Huff was basically saying was that if we use okay, thank you, got it. Okay, what Whelan was saying is basically that. So this is quite curious. I'm not sure why this is happening, but I just need to remember this. When I use the stylus, I see the mouse cursor move, but then when I actually have to move the mouse itself to get the mouse cursor to show up, which is a little confusing. It doesn't show up on the video screen, even though I see it on the video screen. I don't know. It's all right. I'll make sure I don't refer to things that I'm trying to point out with the stylus. So on this x-axis here, we have rain. And this is more rain that way. And then this is the, and I'm not going to try and write sideways. I've learned my lesson about that. We're just going to write corn. I bet there's a way to put text in here, but I'm not going to spend a lot of minutes figuring this out. We're just going to go with this harvest. Corn harvest. I hope that's legible enough for y'all to read. And what we notice is that when there's only a little bit of rain, the corn harvest is pretty bad. As a matter of fact, when there's no rain, there's no corn harvest. And this is presuming we don't have irrigation. We've just got rainfall watering our crop, right? And then we notice that when there's a little more rain, then the corn harvest is a little better. And then there's a little more rain, and the corn harvest is a little better. And when there's a little more rain, the corn harvest is even better. So this is our usual pattern of I'm going to use a pointer now. Oh, the pointer is very... Boy, that is odd. Okay, so I see an arrow when I use the pen, and then when I use the mouse, there's no... there's a little dot. So anyway, I think you can probably see the dot because it's showing up on my recording screen. Fingers crossed. What we see here is that the farmer looks at this, and now farmers, by the way, are smarter than this, but let's say the agricultural economist, let's put it against the economist. The agricultural economist looks at this and says, oh, wow, okay. And then you come along and you say, hey, guess what? This is your normal weather, but what's coming is a 1,000-year flood event. There's going to be 2 hurricanes, both combining and dumping 48 inches of water in 10 days, all on the cornfields. Now, if you're naive to this idea of the correlation, what you'd say is you'd look into the future and you'd say, oh, well, holy cow, that's great because we're going to have the best corn harvest ever, right? Now, you don't need to be a farmer, I hope, to realize that forecasting a giant flood, like a biblical scale flood, is not going to be good for the corn harvest, right? In fact, what you'd expect would be all of it to be wiped out, right? So the challenge here is thinking about a linear relationship when in fact there's probably something else more complicated going on. By the way, I could do the same thing. Let me see if I can. I said I could pan with my touch, but I'm not doing that. So let me just see if I can. Oh, no. Oh, there we go. I can pan like that. And I can erase. Oh, up, eat, er. Ah, there we go. The struggle is real. Okay. Ah, okay. I could do the same thing by looking at quickly, Tim, here. Education with more years here and income. Oof, that's messy. Income here, increasing income that way. What I observe is that people who have 5 years to 8 years of income of education, not very much education, have pretty low income. People who get out of middle school, go to high school, but don't complete high school have better education. Better income. People who graduate high school have even better income. People who go to some college have better income. People who finish a 2-year college have better income. By the way, I don't know if this is actually this sort of direct relationship, but we do know that there are returns to education with income, right? Huff later brings up the challenge of, well, do we know it's really the education that's doing that? But we're not going to play that right now. Don't worry, your education will get you more income. I guarantee it. Can I guarantee that? No. Statistically, we've seen that more education leads to higher income. How about that? And so this is 2-year. Just to give you an idea about what the scale is like here. This is 2-year. This was some college. That was high school. This was some college, but not to a 2-year. 2-year. Here's a 4-year. Okay. And so then if I go out here to a PhD, then I should be thinking ... Aha. Here's Tim Shark's PhD. He's so glad he got his PhD. He has higher earnings than everybody. That's extrapolating beyond the range of the data. This is the kind of thing. If all I had was data 3 to 4 years and I just assumed a PhD would make a lot more, right? Then what I might actually see in real life is a relationship like this, which is that it turns out that, yes, you do get more earnings with education, except for doctoral degrees actually earn less on average than people with a professional degree, right? And so you're better off doing a professional degree like a law degree or an MD, so JD or an MD, or a professional certification program like a doctor in physical therapy or a PharmD. Any one of those degrees pays much more than a PhD does, right? So those average earnings are much higher than we'd expect. So the point being is if we follow this lineup like this, we'd expect PhDs to be up here, and they're not. And then the other interesting thing is look at this unemployment rate. We see unemployment for people with lower education is quite high. People with more education, unemployment rate goes down until PhDs, again, are more likely to be unemployed. So we have to be careful to not assume that the trend just continues with the correlation beyond the range of the data that we have at our hands. We might make some overgeneralizations and miss something important. All right. So then Wieland talks, it's not Wieland, Huff. Huff brings this back to the question of like, well, we know that people with more education make more money. So people with a bachelor's make more than someone with a high school degree. So that's why people go to school, right? And then Huff says, and this is where I bring the Fry meme in here, but can we really conclude that higher incomes are caused by their education? Or is it a matter of people who are more likely to go into higher education are also more likely to end up earning more income? Now, I think this question was a little bit more honest when Huff was asking it because it was relatively rare to go to a 4-year school, and it was relatively common for everyone to finish high school. Today, it's much, much more common. So since Huff wrote this chapter, it's been much, much more common for people to go to a 4-year, and we do see a pretty robust dividend to those years spent in college. Now, it is an open question about student loans and the time spent away from earnings during that time. And that's gotten to be a worse deal lately as the share of student debt has gone up. So these are all fair questions to ask, but I don't think it's as an open a question as Huff made it seem like, which is like, well, how can we ever even tell if it's education? But this is the kind of question that keeps a lot of people awake at night because you can't really tease out cause and effect on education and income because you can't randomly assign people, or you can't easily do it anyway, because you can't randomly assign people to either go to school or go to work, right? That's not the way experiments work. And so his point being is that different kinds of people go to college than don't. All right, there's a bunch of other examples from Huff. I'm not going to go through each one because I have more examples to talk about with y'all right now, but I want you to read through them, which is these questions. Does college cause women less likely to become less likely to marry? We're going to revisit this idea about selection effects or selection bias into samples and sampling problems with sampling, I should say. Does drinking milk cause cancer? Another issue that he brings up and brings data to. This is an interesting case, and it's a little bit hard to understand what he's saying at first, but see if you can follow the logic, which is that he's comparing old women now to young women now, not young women now to their own selves 50 years from now. That's the main problem with this with this causal diagram, right? And then the last example is a great one of about reversing cause and effect between having lice and health, which was that these people that were being subjected to a pretty severe fever, whenever they get sick, the doctors would come and study and try and help them. And then they did a village assay, and they walked around and they tried to figure out who was sick and who was healthy. And one thing they noticed was that almost everybody in the village that they visited that was healthy had lice. But then the people who were sick didn't have lice. And so they said, well, maybe having the lice makes you healthy. But really what was happening was being sick. When you blow a fever, suddenly the lice lice are very sensitive to too hot of a temperature. If anyone's ever had kids with hair lice, one of the primary treatments is to use a special hair dryer and just nuke them. That kills them, right? So they're sensitive to temper, and they jump off their host if their host has a high fever. So it wasn't that lice were causing people to be healthy. It was that getting sick was causing people to lose their lice. That was the reverse causation that they were observing. I want to bring the challenges of mistaking correlation for causation to light with a brief discussion of some of my own research. And specifically, I want to show you some research I did about people's attitude towards climate change mitigation. These questions that I asked people for my doctoral dissertation research, I asked them a bunch of questions about their support for different environmental mitigations, things like increasing taxes on gasoline, signing international agreement, committing the United States and other countries to cut carbon dioxide emissions, end tax breaks and other subsidies supporting fossil fuel production, add an extra charge to electric bills and put it towards efficiency initiatives, require electric utilities to produce 20% of electricity from renewable energy sources. These are individual survey questions. I took them all and I combined them into a single scale. I used to put together a scale, I combined them into a single number, which we can think of as an index of policy support. And what we notice here is that there's a very typical, very expected divide between people who are left-leaning and right-leaning. So people who are more conservative are strongly opposed to adding a tax on gasoline. People who are more left-leaning are about 50-50 split over it. So the reds are opposing and the grays are support. Signing an international agreement, you see that almost everybody who identified Democrat or Democrat-leaning was in favor of it, and then fewer Republicans, right? So there's this partisan split about this. Now, when we talk about something like climate change, one of the things that comes up is that Republicans or conservatives are much more opposed to these things than our liberals. So we want to come up with a communication strategy that will work for them. One of the things I was curious about in my research was the ways in which conservatives might hear different messages or might respond to different messages about climate change and climate policy or climate mitigation policy. So that policy support scale, or you can think of it as an index. We talked about an index earlier in class already. The policy support scale that I created either had a +4 maximum possible, which is strongly, actually I think it was +3 was the maximum value of everything. Agree with everything strongly. Or if you disagreed with everything strongly, you get a -3 scale. And so you could be really in support of all the policies, really against all the policies, or you could be in support of some and against others, or slightly agree, slightly disagree, right? You could be many different places in terms of your degree of support or opposition to all these various policies, combined into one number, combined into one value between 0 and +3 or 0 and -3 if you were opposed to most policy more often than not. Now, what I have here is I have a correlation drawn for you here between people who are left-leaning and people who are right-leaning. Obviously, the left-leaning is blue and the right-leaning is red. Now, interestingly, there were people who were left-leaning who were strongly opposed to mitigation policy. And there were, of course, people who were right-leaning who were opposed to it. But so, too, were there right-leaning people who were in support of mitigation policy, and people who were against it, of course, right? So The trend that I want to highlight here, though, is that I had not just a policy support scale, but also a scale of what we call collective efficacy. This is the belief that we can solve things together, that people, in this case the United States was the context I asked about, but that we can unify and solve problems together, right? So the way I evaluated collective efficacy was you got all the way down to a 1 if you just said strongly disagree to everything, right? But you got all the way up to a 7 if you agreed strongly with a bunch of statements like, we can work together to solve climate change. And climate change isn't a matter of individuals, it's a matter of everyone, right? So those are statements that are about our ability to solve a problem together. What we see is there's this variation in both collective efficacy, right? There's people who are really low in collective efficacy and really high, but also there's a variation in policy support. And so I hope you can see that there's a correlation for both left-leaning and right-leaning individuals, where people who are low in collective efficacy, we can pretty much predict, there's a few outliers, but pretty much predict they'll be low in policy support. On the other hand, people who are high in collective efficacy are pretty high in policy support. Hey, maybe I've unlocked a key here. Maybe if I can juice collective efficacy, if I can tell somebody about collective efficacy, maybe that'll increase their policy support. Do you see what I'm doing? I am presuming that because there's a correlation, my presumption is that collective efficacy causes policy support. I'm presuming that since A is correlated with B, that therefore A might cause B. Fortunately for me, I was running an online survey experiment. You've looked at some data from it already. The ages that we looked at were from that experiment. And I gave people different messages. And so I divided them into groups, and I gave one group the top message and one group the bottom message. There's this little mock-up here. I cut it off in this crop, but it was the Coalition for Renewable Sustainable Energy or something like that. It was a fake organization, and I used clip art of a light bulb with a leaf in it, right? So I had this ad, and the ad message had some other elements to it, but this, for the purposes of this discussion, this was a big difference in terms of these two messages. One, the top message is, you can help. That's an individualistic message, right? And then the bottom message is, reducing the use of fossil fuel, blah, 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 right? Everyone can work together to limit climate change. So the top message is an individualistic message. The bottom message is a collective action message. And my hypothesis then, from this previous slide, is that giving people that collective efficacy juice, let me just move out to this, just to make it clear what we're talking about. I like waving my arms around. My arms are cut off by this circle. It drives me crazy. Let's get it out here. So much better. I'm free. All right. Down here at this end, down here at this end, what we see is low collective efficacy, low policy support. And so then if I give a collective efficacy message, if I move them this way, then I should also be boosting them up here, right? I mean, that's what we'd expect, is we'd expect people to be coming from here and then moving up the scale if, in fact, the correlation had a causal relationship. Boosting collective efficacy should then increase policy support. Let's find out what happened. Where'd I go? There we go. And I'll get my head back out of the way. That's better. All right. This is a diagram of the different... Actually, I need to put myself back into this, don't I? There we go. So, first of all, over here, what we see here is the no collective efficacy message, just you can help message, right? And what we see is that left-leaning or Democratic-leaning individuals were in favor of policy support. This is our error bars, the little squiggle there, but a policy support of about 1, right? So more in favor than against most of those policy positions. Whereas if we look at the right-leaning people, the Republican-leaning people, they were about 0. They were about evenly split between in favor of some policies or against some, or the total sum effect was neither in support nor against the policies, right? Look at the difference here when we come over to this collective efficacy message where I said everyone can work together to limit climate change. Notice, first of all, that it worked a little bit for the Democrat-leaning people. It wasn't a significant difference, but the point estimate was slightly higher. So it increased people's policy support by a little bit on the liberal side of things, right? But look what happened to my message over here. Do you see what happened? For people who were right-leaning that got the hey, everyone can work together, the collective efficacy message, it actually decreased their policy support. So instead of being about equal to 0, it was actually worse than 0. It was lower than 0. So you've got to be really careful when you look at a correlation. This is the big message. And by the way, the reason I tested this was because I was being careful about this, right? If you look at the correlation, you just assume that it's a causal relationship or that you understand the mechanism of the cause, it can backfire on you. And that was a big lesson. It was part of the reason my dissertation research was decent, was because I found this phenomenon. People were like, ooh, we didn't expect that. And that's always interesting to people when you find an unexpected finding. All right, enough tooting my own horn. So that's that for the Huff reading and that other stuff. I have been going on a little long, but 30 minutes. It's actually been okay. I want to get into the good stuff here. Now, there's a bunch of short articles right here, and you know what? I'm going to come back to these in a minute. What I want to end up on right now, and I'll take maybe 10 minutes, max 15, to give you this example of why we care about correlation to set the stage, and then we'll come and work through all these examples in another short video update. I don't want to do it all because it'll be too much, but I do want to do a little bit right now. So let's go back to this, honestly, which is this first page. I want to just pull that up. We just talked about all these. Oh, when I get my head out of the way again. There we go. When we talk about correlation not equaling causation, we spend a ton of time talking about how, well, you know, it could be anything or it could be nothing. And I saw this website called Tyler Vegan. And this is where I want to caution you not to get cynical, because I think a lot of people come through an intro to stats class or even a data and discourse style class like this, and they come out jaundiced, and anytime they see any kind of evidence that's even slightly correlational, they just say, well, that's correlational, and poo-poo it. So first of all, we have to be careful to check our critical thinking about this and make sure that we're not doing the motivated cognition that we've already discussed in our class about only thinking critically about correlation doesn't equal causation when it's something we don't agree with, and then blindly accepting it when it's something we agree with because it's common sense, right? So be very careful about that. Second of all, we do use correlation a lot in social science, and we do like it, and we do use it as evidence. I want to take the last 10, maybe 15 minutes here to give you an example and explain what it is that makes a correlation more meaningful than just, oh, I found one, it must mean something. What is it beyond just, oh, there was a correlation that we need to make a correlation have some kind of oomph or impact or meaning to us? Because otherwise we'll look at that Tyler Vegan website and start worrying about margarine consumption and Nick Cage doing any more movies, right? He's a killer. He's a secret killer. No, we don't believe that for a second. So what is it that we need in addition to a good correlation? Let me get into that idea by giving this excellent example from Proceedings of the National Academy of Sciences. Robert Thompson is lead author on this massive publication. It was his dissertation research, I believe, and he's been working on this since too. Anyway, he is a sometimes follower of the channel, so I will make sure I tag him and he tunes into at least this part of it to make sure that I got all my facts right about it. The paper is really interesting, and if you're interested in social psychology in particular, I'd recommend you check it out. But it's a fascinating topic. Let me set the scene really quick for you here, which is that the topic of this paper is about relational mobility. And relational mobility is, to my understanding, it's not my field, so apologies if I'm getting it a little bit squidgy, but relational mobility refers to the ability, people's individual ability to break and make new friendships and break family relationships. In other words, Some people, and most of the evidence of this is based on survey information, to my knowledge, but you can ask people and say, would you ever, cut off communications with a close relative, like your father or your mother or aunt and uncle? And some people would say, yes, of course I could, if they did something bad. Other people would say, like, no, I could never, right? That wouldn't be proper. And similarly, if you have a strong sense of friendship with people you've known since your late teens, early adulthood, and you don't feel like you can make new friends in your 20s or 30s, then you have low relational mobility. If you feel like you could move to a new city and make new friends in your 20s or 30s, and you might have your friends from before, but it's okay if you grow distant from them, then that's high relational mobility. So by itself, hopefully everyone understands that different people are different that way. But what these authors really get to is that we see strong differences in relational mobility at a country level. Now, again, there'll be individual differences within the country, within subsets of the population. There might be ethnic divisions or other cultural divisions that have higher or lower relational mobility. But looking at a country as a whole, there are country level effects, and this is a map of that difference. Now, they did this massive study with, I think it was 100,000 or something surveys. Let's find out. I don't see their N on here right away, but it was a massive survey that they did this study for. Anyway, they didn't get data on every country, but they got a bunch of countries around the world. And what they found was that some countries are very low in relational mobility. That's the left end of the scale there, the blue color. And some countries are very high in relational mobility. In other words, people thought, well, I could, if I needed to shut a family member out, I could. If someone made me really mad, I'd have no problem not talking to them again, right? Right? And so this scale then is this idea of place, and the average is right in the midpoint. That's how they set the scale up here. But places that are high relational mobility are more mobile that way than are places that are low relational mobility. You think about the consequences of this kind of stuff. Who would have an easier time leaving a job and starting work at a new firm? Who would have an easier time being relocated by their work to a new city? Who would have an easier time adjusting to a divorce and therefore would think less about getting a divorce because of that, right? So there's consequences for being on this end of the spectrum versus this end of the spectrum in terms of what kind of effects we might see. Now, there's all kinds of interesting stuff in this paper, and I wish I could go through all of it with you, but we got to get to the details here about correlation. So one of the things that I thought was so interesting about this is that this idea of historical farming and threat. And I read this paper when I was traveling through Japan last quarter. I had a almost 2-week stint traveling through the northern Tohoku region, and I was looking at the cultural landscape of Japan, and I was documenting it for my students, my geography students, taking videos and taking photos and just taking notes. I can't speak Japanese, so I didn't talk to anybody hardly. But what's really interesting to me about this is that, and this paper, is that Japan is very low in the relational mobility scale. So the idea of family ties being very strong, the idea of friendships being firmly established and not changeable easily, right? It's very tied into this Japanese cultural difference. And now here is where we get into this correlation. And I need to get my head out of the way to get Japan in there. I'll do the talking body again here. There we go. So I hope you can hear me okay over here. I like to shout anyway. I'm sure you can hear me. So let's take a look at the scale here again. And what we see is that way over here in the corner is the relational mobility measure is here. So I already discussed what that measure is in my own language, right? In my own version of it. But high relational mobility is up here. Low relational mobility is down here. You can see the countries that were colored in bright red, like Mexico, Venezuela, Brazil, Colombia. The United States is pretty high over here as well, right? 0.2, not quite as high as Mexico, but 0.2. So these places that are a little bit more easily friendships made and broken, family relationships made and broken, is up over here. The scale that they also looked at here is this scale down here called the Interdependent Subsistence Style Index. And that sounds really complicated. What you need to look at is this scale right up here, which is, this is rice agriculture, and this is herding agriculture. This is where we get really just, it's a perfect example of why correlation is meaningful. Because what we have here is not just, oh, that's a coincidence. Who could have known that places that were low in relational mobility high in relational mobility would have been low in interdependent subsistence and more herders, right? And who could have guessed? It's just a coincidence. How do we know it's not spurious, right? This is the cool thing, is what we have here is we can tell a story that makes sense about what is causing this. And also, we know which one came first, so we know which one would be causing the other. We could argue. You could argue cleverly reverse causation, but we can be pretty confident about the causal direction, I think. Here's the story. We see that in some societies, rice is a dominant form of agriculture. Rice is extremely interdependent. The rice is grown in fields that have to be kept flat because they have to be flooded. They can't leak because they have to be kept flooded. The rice, when it's planted as shoots, matures underwater. You have to plan out how you're going to flood the fields. And if you have a lot of people, you've got to have lots of fields. You've got to organize your society to set it up so you have to, whose field gets flooded, who helps maintain the field, who helps with the planting, who helps with the harvest, who helps maintain the levees and the dikes and the diversions and the dams and the aqueducts on the valley side, and who controls the water so that nobody's rice field goes dry. To do all that, to be a successful farming society that is that interdependent, that dependent on other people's cooperation, means that you need to have strong social ties. So argue the authors. And so I agree, right? On the other hand, if you're over here and you're a herding society, in other words, what do you need? You need to have a small family group, maybe a few friends, but you're out with your animals and you're herding them around. You got to worry about guarding them from predators. Fine. You got to worry about finding them some fresh grass. Okay. But it's not a complex social system around agriculture. It doesn't require a high degree of social interdependence to succeed at herding compared to succeeding at rice agriculture. By the way, other forms of grain agriculture are over in here. Forms of like mixed crop and livestock are over in here. They have a scale for this and they establish it. So some countries, you can see here, there's countries that are all across the range in this, right? In terms of the extent of interdependence of their agricultural systems. So this is a really cool thing for me, and I you can tell I'm dorking out about it, right? But this is the cool thing for me, is that they've established this thing, and what they said was, wait, we came up with in the year 2018, I think the research was a couple years before that, but we came up in the 2010s with a scale of how relationally mobile people felt who were like sitting there tapping on their phones on Facebook, right? And about how they felt about their in-laws and how they felt about their friends. And it turns out that we can predict how people feel about their friendships and the mobility of their friendships and their family ties and the mobility of their family ties based on the agricultural history of that region that they're from. Isn't that cool? In other words, you tell me if it's a rice agricultural place, I'll tell you that there's low relational mobility. You tell me it's a herding place, I'll tell you there's high relational mobility. So that's cool just in and of itself, right? But what I really want to get back to here, and this is the whole point of bringing this into you, besides just me being a dork and being so excited about it. What I want to get back to about this is that what we need in addition to a correlation is we need to have a plausible causal mechanism, sometimes called a causal story. I just told you a causal story. I told you what it was about farming that caused societies to develop stronger or weaker relational mobility, right? That required it or didn't require it as much about the society. Now, back to the cause and effect. Which came first? Rice agriculture and herding agriculture, or social interdependent networks? You could argue that people were strongly socially interdependent and then said, hey, let's farm rice. I know, let's farm it, right? But probably not. What we know is that agricultural hearths originated back in prehistory, variously around the world, and then those practices diffused based on locally available crops and favorable environmental conditions. So we have a reason to believe that the crops came first, the agricultural practices came first, and the society developed in part because of that. So in geography, we call that environmental determinism, by the way. And we like to be shy about that because it doesn't always explain everything. But in this case, it's a pretty cool story. One more compelling bit of data. The authors did the same thing, but they didn't just look at this herding versus rice agricultural. They also looked at, let me pull it up here, where it is, there we go. They also looked at the degree of threat experienced in each place. And they had a measure of historic threats, which included a history of war and war losses. So it wasn't just being at war, it was also impacts to war. So Japan, for instance, has felt pretty severe impacts to war because they've had war on their soil a lot, right? Whereas places like New Zealand and Australia and Canada and Sweden have had very little impacts of war and losses from war. Same thing too for risk of nuclear disasters, risk of extreme weather events like hurricanes or typhoons, droughts, floods, and the like. And so what they found is that some places have a lot of historical and ecological threats, and sure enough, they have low relational mobility. And then some places have very few historical in comparison, right? Every place has some, but in comparison, relatively few, and they have high relational mobility. Now, these countries don't map out exactly the same on this correlation as they do on this correlation, but we still see the same pattern. And again, we have a plausible causal mechanism, a plausible causal story, which is that those places that had the most historic and ecological threats, having social cohesion, having friends that you can count on through thick and thin, having family members that would never turn you away or disown you, is really important in a place where there's a lot of risk, because those, if they turned you away or if they shunned you, then you might not survive, right? And so survivors survived because of interdependence in this situation. Whereas over here, not so important, and we have a little bit more of this sort of independent streak, if you will, right? Because there weren't as many historic threats to be dealt with through social interdependence. Anyway, I've talked myself hoarse now, and time-wise, I went 15 minutes. That's the end. I'm going to end it right there. I hope that was interesting to you all about talking about this. And the most important part is that this answers this question is, when we get into A correlating with B, and I just spent a whole lot of time last lecture and a little bit of time this lecture saying, well, it could be anything, right? How do we start thinking that A might be causing B? Or what leads us to think that a correlation really is important? What do we need to know besides just that there's a correlation? And the answer that we come back to is we need to have some kind of a linkage, a causal mechanism or a causal story that explains why the one thing is causing the other. All right, I will check back in a few days here. I don't know exactly when I'm going to get on to the rest of this stuff, but I hope to get it done tomorrow morning. Fingers crossed. Bye-bye for now.